Okay, brown dwarfs. First question. Describe how a star is formed. A star is formed when large clouds of dust and gas clump together or aggregate under their own gravity. That's it. That gets you the 2 marks. So, large clouds of gas and dust aggregate, 1 mark, and clump together under mention of gravity, 2 marks. Okay, next bit. Describe the process of nuclear fusion. Right. Nuclear fusion is when 2 atomic nuclei fuse together to form a larger atomic nucleus. Okay? Use the term atomic nuclei in your answer. Don't say atom, because an atom includes the electrons, and the electrons aren't really relevant here. Nuclear fusion is when the atomic nuclei fuse together to form a larger one. Okay. Why are we now able to observe brown dwarfs? Okay. In the description of brown dwarfs at the beginning of the question, it tells you that they're not visible to the naked eye. They don't emit visible light, but they do emit infrared light. And you have to suggest why we are now able to observe brown dwarfs. Well, the reason is we must now have equipment, telescopes, that can sense infrared light. Whereas when they were predicted but we weren't observing them, we weren't able to detect the infrared light from them. Okay. In the 18th century, scientists predicted or suggested that planets were formed by a cool disk of matter. So there's a star. They suggested there were cool disks of matter surrounding the star, and that the planets were formed from these cool disks of matter. The question is, what would scientists have predicted was taking place in other parts of the universe? This is a really stupid question. They tell you in the question that in the 18th century, scientists predicted that there were cool disks of matter around stars, around young stars, and that the planets were formed from them. And then they ask you, what would the scientists have predicted, or what would the scientists have suggested how planets were formed in the 18th century? Well, I've just told you that. I don't get it. So you just have to regurgitate exactly what they've just told you in the question. And so you just say that they would have predicted that other planets and solar systems were formed from these cool disks of matter. It's a stupid question. I don't understand it. Let's just move on. Okay. In the 1980s, young stars were observed using our telescopes with cool disks around them. The question is, what was the importance of these observations? Well, or what does it say about the theory in the 18th century that planets were formed from these disks of cool matter? Well, it's a classic thing in science. You come up with a theory, and then later you see evidence that supports that theory. What it does it suggests that the theory is a good one. We see in the 1980s that there are indeed cool disks of matter around young stars. That suggests that the theory which said that planets form from these disks of cold matter suggests it's probably not probably correct. It supports the theory. That's the phrase you should use. It supports the theory. Okay. Earth contains elements heavier than iron. Right. Why is this evidence that our solar system was formed when a massive star exploded? Well, simply because only elements heavier than iron, they can only be formed by the explosion of a massive star. So if planet Earth and our solar system is full of elements heavier than iron, it must have been formed by the explosion of a massive star. That's it. Simple as that. So iron has the atomic number 26. It's got 26 protons. All elements from hydrogen to iron, so hydrogen 1 proton, so 1 to 26, they're all formed by nuclear fusion in a star like our sun. 27 and beyond, all the heavier elements, they're formed by the supernova explosion. I think it's a supernova explosion. The explosion of a heavier star. And they're two different processes. So, yeah, we on planet Earth must have been formed by the explosion of a massive star.